So you should be very familiar with how to plot a graph. The thing that we change or something related to it goes on the x-axis. The thing that we measure or something related to it goes on its y-axis, and we get our data hopefully in some form that will give us a nice straight line. And this is, perhaps typical of a set of data. There is a certain amount of noise distribution around it, and what you would do is you would fit your line of best fit through that data. Now, what do we mean by our line of best fit? Well, we should be minimizing the distance between the data points and the lines, and this is both the horizontal and the vertical distance. If you minimize the horizontal distance, you've normally got a pretty good guess at minimizing the vertical distance. This is technically called a least squares fit, essentially because we're trying to square the distance between the two axes, because then it doesn't matter whether it's above or below the line. Now, if I take two lines and run them in parallel to that line of best fit and kind of stretch them out, as if like those curtains that are on a pulley, so that they move out equidistant from that center line of best fit. And I want that line there to contain 2/3 of my data points. So when it contains 2/3 of my data points, I'm going to stop and I'm going to draw my parallel lines. And what can happen between the highest and lowest value, I can then draw two new gradients based on those new lines. So I can get a steeper gradient and a more shallow gradient. And this now gives me my error in the gradient. So previously we've been able to work out errors in single measurements, but now we can get an error off a plot. I can take this further to work out an error off an intercept, which I can just either read off the y-axis or I can calculate from a single point. Whenever you're drawing a gradient, you should never use data points to do it. Just as a reminder, you should always use points on your line of best fit. Hope this helps. Bye.